tomorrow will be better. Let's stay a little bit more in mathematics and more specifically in exponential equations. Unfortunately, many students shy away from exponential equations. Yeah, I understand. This is because at first sight, it looks cumbersome, it looks complex, but it's far from being what you're thinking. The moment you just catch the trick in exponential equation, you're very good to go and you'll enjoy it. And what's this trick I'm talking about? The secret to exponential equations is your mastery of all the laws of indices and logarithm. If you have these two things at the tips of your fingers, you'll be good to go for exponential equations. Now we have an equation here. Of course, no need to say find x, alright? That's the target. Let's find x in this equation. Now, without wasting time, solution. Now, from experience, I have observed that many candidates come here and then they misuse one of the laws of logarithm, which is, let me write the correct law and then I write what most students misuse. The correct law says log of a minus log of b gives us log of a all over b, written as so. But a lot of candidates, when they are faced with log of a minus b, they are tempted to say it is the same as log of a divided by log of b. These rules are not the same, okay? This doesn't exist anywhere. So be very careful with this, all right? So this is a correct form of the law, but this is not what we're going to use right now. We're going to use another form of or another law of logarithm. Now this time around we're going to use this property of law which says log of a n is equal to say n, implies that a will be equal to n raised to the power n. Alright, this is a property of log we're about to use here. Let me write correctly. Right, very quickly we have that. Let me copy this again. Negative 0.7x minus 9 is equal to 1 plus 5 log of 5. Now we will say from log of a n is equal to b, it implies that a is equal to n to the power b. Now look at this. We also know that this is log. If nothing is on this base here, it means the base is 10, alright? So let us apply this to this. This implies that in this case, our a is all of this up here, our n is 10, and then our b is whatever is here. It doesn't matter how big it looks like, alright? Don't get scared. Alright, so a, which is, I can put it in the bracket to minimize mistakes, x minus 9 is going to be equal to n, which is 10, and then raised to the power b, which is all of this here. Now, for the sake of simplification, some might just punch in your calculators and then reduce this to something which is less cumbersome, alright? So, at this point, watch what I'm going to do. All I have to do now is to send away this negative 9 to the right side. Okay, so if I do this, I'm going to have that negative 0.7x alone to the left will be equal to 10 to the power 1 plus 5 log 5, and then negative 9 going here becomes positive 9. Alright, so at this point we are almost done. Yeah, this is a familiar form to you, alright? Again, I repeat, it doesn't matter how cumbersome or how complex it looks like. It is what you know, and the rule you know applies here. So how do we get x here? You simply divide both sides by negative 0.7. Yeah, alright. So this goes like this, and if you do this well on your calculator, you should be able to have the answer. X is going to be equal to 7. Something more or less like this. Of course, there's a negative here. X will be equal to negative this. If you punch well on your calculator, alright? This is how simple it is, because tomorrow will surely be better.